Chapter 2, Section 5, Inequalities. In this section, what we're going to do is we're going to take our knowledge for solving equations and apply it to inequalities. So the first thing I want to do is I want to review our inequality symbols. This symbol is a less than symbol. This symbol is less than or equal to because it has the line underneath it. And these two do not mean the same thing. This means that A, the left-hand side, has to be less than the right-hand side. This one means that the left-hand side can be less than or equal to the right-hand side in order for it to be a true statement. This is your greater than symbol, and this is your greater than or equal to symbol. To solve an inequality, we're going to use the same process as solving an equation, with one exception. If you ever have to multiply or divide by a negative number while solving the inequality, you must turn the inequality around. Then these two examples here on the bottom are the reason why. If we have a true inequality statement, 2 is less than 5, and we multiply by a positive number, we're going to get a positive 4. We're going to get 8 is less than 20. And that's still a true statement. However, if we multiply this exact same inequality statement by a negative 4, look at what we get. We get negative 8 less than negative 20. Well, negative 8 is to the right of negative 20, so it's greater than. So when you start turning the sides of the number line, in other words, this goes on the other side of the number line, and that's what a negative does. It takes you to the other side of the number line. Then you're going to have to turn that inequality around to get a true statement. Now, when we solve these inequalities, what we're going to do is we're going to use the same processes, but our solutions are going to be a little bit different. And the reason being is because when we solve an equation, if we take this equation on the left, for example, and we solve this, we're going to get x is equal to 2. And that's just one solution. X can't be anything but 2. On the right-hand side, when we solve this inequality, we're going to get x is greater than 2, which means x can be any number greater than 2. So if you think about that on a number line, and you think about all the numbers that are greater than 2, that's going to take you all the way to positive infinity. So solutions to inequalities can be expressed in 3 different ways, and the reason we're going to express them in these different ways is because you do have more than one solution. You have an infinite many solutions. So the first one that we're going to talk about, we're not really going to write our answers this way, but the reason I want to talk about set notation is because when you look in the back of the book at your answers, it's going to be written this way, and also when you take your final exam, which is multiple choice, the answers are going to be written in set notation as well. So a solution for this one, for example, if we had the solution to this inequality up top, which we said was x is greater than 2, what's going to happen is we're going to get, in set notation, we would have our brackets, and we'd say x such that all x's must be greater than 2. So that's just set notation. And like I said, that's going to be your answers in the back of the book, and possibly your multiple choice answers on the final exam. But this is the part that you're looking for. Doing in class or at home. The only thing that I'm going to require you to do on the number line is actually put the number that's in question. So 2 in our example is the number that's our beginning point, basically. And it says that x has to be any number greater than 2. Well, we know any number greater than 2 is going to be to the right of 2, so we're going to color that in. But we have to use a symbol to signify that we're starting at 2. Since x cannot be equal to 2, we're going to use a parenthesis. So you need to understand that parentheses mean that x cannot be equal to, whether a bracket's going to be used if x can be equal to. So the other one that we're going to talk about is interval notation. Basically, in interval notation, what you're going to do is you're just going to basically copy what you see on your number line. So we know that we go from 2 to positive infinity, and we see that x cannot be equal to 2. I know that because there's a parenthesis there, and infinity can never be reached, so you can never be equal to infinity. So infinities always carry a parenthesis, and if you'll notice in this interval notation, every time you see an infinity, you see a parenthesis. Even negative infinity, which is going to be the negative side arrow, that's still going to get a parenthesis. So note the use of the square bracket to indicate the inclusion of endpoints. We will use these when you see the less than or equal to symbol or the greater than or equal to symbol. So parenthesis means cannot be equal to, and bracket means can be equal to. Okay, so we're going to solve graph, and we're also going to write it in interval notation. So to solve these, again, you're just going to use the techniques that we learned in the previous sections of chapter 2. So to solve this inequality for x, basically we're going to minus 5 from both sides. And so we'll have 2x is greater than negative 6, and then we'll divide both sides by 2, and so we're going to have x is greater than negative 3. Now, the statement that I made earlier is this: if you have to multiply or divide by a negative number, that is your key word, by a negative number, that's when you're going to turn around the inequality. So look, we divided by a positive number. Yes, I know that we divided it into a negative number. That doesn't have any bearing. It's what you divide by or multiply by. So since we multiplied or divided by a positive 2, we're not going to turn that inequality around. So here's our solution. That's asking you to solve. And then to graph it, again, negative 3 is our starting point. X cannot be equal to negative 3. I know that because I don't see a line underneath the inequality. And it is going to be greater than, so we're going to have a parenthesis since it cannot be equal to, a parenthesis at negative 3, and greater than means we're going to color to the right. So the problem on the right, we're going to minus 4 from both sides. So we'll have negative 5x is greater than or equal to 5. And we're going to divide both sides by a negative 5. So we're going to have x is less than or equal to negative 1. So a lot of things going on in this problem. Number 1, we had to divide by a negative number, so notice I turned the inequality around. Number 2, this is a less than or equal to symbol, which means we are going to use a bracket on our number line. So negative 1 is our starting point, x is less than, so we're going to have a bracket go into the less than side, left, and we're going to color. And then our interval notation this time, you're going to read your graphs from left to right, so your interval notation needs to be from left to right as well. So we're going to have from negative infinity to negative 1, and we're going to have a parenthesis at your infinity, because you can never equal infinity, and we're going to have a bracket at negative 1 because of this equal to symbol. Alright, let's try 2 more and see what happens. The one on the left, we're going to combine like terms, so we'll have 3x plus 3 less than or equal to 4x minus 4. So once you simplify, we need to start moving things around. So I'm going to take the 3x to the right. So we'll minus 3x from both sides. And then I'm going to add 4 to both sides. Now, I did this for a couple of reasons. Reason number 1 is if I took this negative 4, this 4x to the left, that would give me a negative 1x over here, and I'd have to turn around and divide by a negative sign, which is fine as long as you remember to turn your inequality around. The other reason is this: I wanted you to see that when you come up with a solution like this, the graphing and the solution set, the interval notation, is going to look a little bit different. So you have to be able to read this. This says 7 is less than or equal to all other numbers. So on the number line, when you do this, 7 has to be less than or equal to all other numbers. So all other numbers have to be greater than 7. And I know that that can be a little confusing, so just be careful and understand what we're going to write. So you have to understand that if I turn this around, that's going to be x is greater than or equal to 7, which is exactly what I graphed. So be very careful with what you're doing. Alright, the problem on the right, we're going to distribute. And then we're going to combine like terms. And then we're going to continue to solve. So we're going to add 32 to both sides. And this is what I was talking about a while ago. Since I have a -1 here, I have to divide both sides by -1. And when I do that, I'm going to get x is greater than a -36. So -36 is our starting point. X is going to be greater than, cannot be equal to, so it's going to be a parenthesis, and we are going to color to the right. So our interval notation is going to be open parenthesis, -36, all the way to positive infinity, close parenthesis. So just a few things that you need to remember when you solve these inequalities. Number one, you need to know which symbol you're dealing with, less than or equal to, or greater than or equal to. Number two, you need to know how to graph. And number three, you need to know how to write interval notation. And the last one, which is very important, anytime you have to multiply or divide by a negative, you've got to turn that inequality around. So let's try these problems on page 95 and 96. If you need any help, go back and look in the video or look at the examples in your book.